So today is the launch day for the new Mac Studio. Check this out. Right here it is. Mac Studio. Check that out. Isn't that crazy? This is the M4 Max. This year, they only upgraded to the M3 Ultra, and this is the M4 Max. So this has even greater technology, but the other one is essentially double this in performance. I actually been wanting this for a while now. We didn't know if this is going to come out in March or the WWDC event, but it's here. Essentially, I needed this computer to be here at the studio, in my YouTube studio. We're going to be testing whether or not, how fast it is with video encoding, how fast the disk is. We'll do some benchmarks, be able to use this for AI here at the house. So I'm going to run containers on this. There's a whole bunch of stuff I'm going to be doing with this. It's going to be a file server. This is a lot. There's a lot of stuff. And yeah, I'm super excited about it. Let's get right into it. I actually did not think that I would be unboxing this. This box is just massive. It's actually really heavy compared to like a lot of other Apple products that I have unboxed over the years. This is the 14-core CPU, 32-core GPU. Right here it has 4 Thunderbolt 5s. They can do 120 gigabits per second. It has these USB-A port, figuring these are at least super speed, right? And then this is a HDMI, in case you don't have a way to do your video this way, headphone jack, and of course the power. And this actually comes with a 10 gig Ethernet. Front, we have 2 USB-C ports and a memory card reader. This is the 36 gigs of unified memory. What am I waiting for, right? Here we go. I need to tuck in the handle, I think. Here we go. Oh my gosh, it's like, this is almost too massive for my little room. Look at that. There it is. Oh, wow. This is pretty exciting. So looks like these both come apart like this. I don't have enough room in here. Can we just pull this out? Wow. Look at that. Okay. So I'm going to move the box aside, put this down here. In the box here, we have a power cord. Is it really just this and the power cord? I think that might be it, the paper thing. You buy everything separate so that you can pick out your keyboard. Just a little side note here. I'm going to be using this. This is almost a vintage keyboard at this point, but I had one of these. So for now, I'm going to be using that. This is a Magic Trackpad, the latest one that charges via USB-C. I don't know if there's really anything in here. Did we get any stickers? I don't think we did. This is going to basically be sort of like a server machine. Look at that. Wow. That is just, it's large, but it's still small. You know what I mean? Like, it's still small enough that you could take this on an airplane, like on vacation if you needed to. You know, especially with some of these spec'd out ones that with a lot more storage than this. They're ridiculously expensive, right? But, you know, it is pretty cool. This is actually going to be like probably one of the most easiest unboxings of all time. But yeah, I feel like it's time to get this puppy plugged in to my studio. Look at that Mac Studio right there. Look at that. Isn't that? It's shiny. I'm going to be powering my studio in here. I have several monitors. It's actually been a few days, and that's because it's somewhat of a complicated environment in here. There's a lot of stuff going on, and I sort of had to readjust everything because typically what I would do is I would come in here and I would drop my laptop and I would plug it into a dock, and then I would transition that laptop into studio mode. Well, now I have a permanent fixture in here. The reason I got this Mac Studio, basically I needed a server. I needed a way to control my studio. I wanted to be able to do AI, Docker containers, and video editing, home automation. This thing can do all that, even though it's the base model of the M4 Mac Studio, right? It's got 36 gigs of RAM. It's got 512 gigabytes of storage. With the Thunderbolt 5 ports, we can add more storage on later. One of the things that I've been struggling with is editing 8K. I think it's like 3 years ago when I got this computer, which is actually what's controlling my TV behind me. This is the original M1 MacBook Pro, and this was the 16 gig. This guy could edit 8K, right? It just could barely do it. You know, my other Intel Mac at the time couldn't do it. Of course, now I'm editing VR content. This camera that I'm filming on right now actually takes this lens. This is the Canon dual fisheye, and you got to record in 8K for this to look good in here. I'm going to show you a little bit of that here in a minute. First, I'm going to use the Apple Vision Pro. I'm going to show you what this looks like. This is my Mirror Vision Pro, which just allows me to look the camera in the eyes. It's a teleprompter, but for visual inspection, for framing. I can also see myself over here. That is being controlled by the Mac Studio now, where before I had a dock and I had a laptop and it was more cumbersome. So I wanted to give you sort of a size comparison. This is an Apple TV. I'm of course using the Apple TV to run my television. This Mac is substantially bigger than an Apple TV, but isn't it similar? Like, look at that. It's like even like you can tell it's the same rounded rectangle type of thing that, that Apple's done for years. I did fill all the ports in the back, the same amount of ports as my dock had. So I was pretty happy about that. The keyboard here. This keyboard, I had one heck of a time getting this to pair. I wouldn't recommend this. I would recommend buying their keyboard. However, just be prepared to try and try again. Eventually it will pair. What was happening is the numbers that you're supposed to type wouldn't come in. I kept pushing the little power thing. I just wanted to use this to save money, and I like the keys, and I make less typos with this keyboard. I like these arrow keys, where some of the smaller keyboards, they use the other arrow keys, where the left and right are real big. I don't know, that just feels weird to me. I like my keyboards to be somewhat consistent between computers. It just helps my brain. I got a budget, a YouTuber budget I gotta stick within here, Okay?
Several days later.
This ended up not really working out. The problem with this keyboard, at least currently, is that if you reboot, you can't log in. So you have to have another keyboard to log in. I actually purchased another keyboard, so I don't know if I'll use that one or not. Probably not. So anyway, right up here on the screen, as you can see, this is the Mac, and it is pulling about currently about 30 watts of power. Now this is more than usual because it's using about 10 watts of power to do this recording that we're doing. I've got several applications open. I am going to be using iStats. I'm a fan of iStats. There's also MacStats, which is an open source version. If you're interested in monitoring the stats of your Mac, it's really cool because it puts it up top up here. There's a lot of cool stuff. You can even get the weather. I think I pay for the weather. Maybe it is a paid program and it's not sponsoring this video in any way, but I've just grown fond of iStats over the years. As you can see, I'm running quite a bit here. This EOS utility is what's capturing or running my camera and my teleprompter so I can see myself and look you in the eyes. QuickTime is what's doing the screen capturing here, as well as showing this window here, which is connected to my iPhone so we can see the wattage and stuff that's going on. This is usually around 20 when it's like when it's asleep. And what I mean by asleep is mine's still awake. If you turn yours off, this will go to 0 on most by default. But if you're using it as like a server, 20 watts is what I've seen. We're gonna go ahead and open Premiere. This is the video I wanted to show you. So again, there's post-processing involved with this because this essentially puts 2 fisheyes on the sensor. And so the R5 has an 8K sensor. As you can see right here, this is my Premiere timeline that I had pulled in, and I'm gonna show you. Let's go ahead and this is just one clip that I had recorded, and I'll show you. I'm playing it back, and as you can see, I'm gonna make it full screen. It is basically, this is the left eye. You can see the lens right there. You can see a little bit of that curvature of that lens. The one lens films the other one. This is why we have a nose, so our eyes don't see each other. And you can see the snowflakes are fine. I recorded this in 8K. This is a special place for me that near my house. I've climbed up this thing, and I haven't done it in a while. I did it when I was a kid, and I can't seem to do it now. Playing 8K just fine, right? There's no proxies. If I had proxies, I would have had this here turned on. So there's definitely no proxies. Every once in a while, you'll experience a lag, and it's because Adobe is like processing forward in the clip, and it hasn't built previews for it. I don't know how to explain it, but I know sometimes it makes its own previews, and I have seen some lag there. If we go and here and we select Reveal in Finder, it will bring up Finder, and then this clip here, if I double click it, this is actually what it looks like. Now, what's weird about this is actually the way it was filmed. So it's going to be reverse. So the right, how do I explain this? I believe the right is the left and the left is the right. So those get switched in Premiere with this driver. There's also another way to do it with this VR encoder, and I've tested that as well. It runs extremely fast. But anyways, this does it directly in Premiere, and it actually stretches it out. If we go back into Premiere, you'll see it's like stretched it out. And so it's doing a lot in this clip, being that it's 8K and having to sort of stretch that out and stuff. So, oh, and you know what I forgot to show you? Let's pop back in there real quick. If you watch right here, you'll notice we're already using more power just with having Premiere open. It's like not using much right now, but once we start playing this without proxies enabled, you can see the wattage it doesn't go up by too much. We're using about 56 watts now, which our baseline was around 30. So about 25 watts to play this. And you can see it's using 31% of the GPU to take this 8K footage and flip it, stretch it out, and I'm sure we could color grade and stuff. So we have leftover GPU, which that's good. CPU isn't really get used that much in Premiere these days. It's mostly just sitting on the GPU as it's processing this clip here. So yeah, you can see that that's you know, there were about 62, so somewhere between like 25 to 35 watts of power just to run this. And I've had this in here for 4 days, and you can see it's only used 18 cents of electricity. I think it's 4 or 5 days now that I've been playing around with this. And our next test is going to be the Blackmagic disk test, which this is always a fun test to do. I've done this before. Essentially, you just hit start and you let it go for a bit, and essentially it does the read and the write speeds. And you can see like the first one, it actually did better at, but yeah, just go in here. It's getting about 5 gigabits read and about, oh boy, I lost my window. Oh, that's really weird. I wonder why I lost my window. And this is this needs refresh, but hold on here. I actually think this caused EOS Utility 3 to crash, but I'm still recording on camera, so not a huge deal. But I'm gonna go ahead and hit stop. But you can see all the green here is checked. So the read and write speed from the internal disk has no problem really at all. We're gonna stand by while we get EOS Utility open. Oh, big rainbow wheel. Okay, why? Okay, I think we're back in business. I actually recorded this and I didn't have good mics, so I'm not gonna put you through that. So I'm reshooting this. So anyway, the last test I wanted to do was really to show you how this performs with AI models. And so it's becoming a thing where we can run AI models locally. And if you have enough RAM, or on a Mac, it's unified memory, but on a PC, you have to have enough RAM in your GPU and your graphics card, where on a Mac, that part is shared, right? Because it's all in the one chip, the M4 Max chip, right? So it has all these GPUs that have access to memory, just like the CPU would. So this computer has 36 gigs. We're gonna have it do something that I did as a kid. I had dial-up internet and I was trying to learn how web servers worked. I was about 13 years old and I was writing code to essentially become a web server. There's use cases for this, but we're going to have AI do that with some Python code, because AI likes to write in Python. And this is the Chinese DeepSeek R1 32 billion, which is a bigger model. I've actually been testing the 8 billion, the 14 billion, and the 32. And we're going to look at what it takes. So I wrote this prompt, and I've done this a few times. Each time I get a slightly different result. In this prompt, I said, can you write me a Python script that acts as a server listening on this address? Be sure to actually follow normal TCP/IP handshakes. This is important, as well as reading request headers and then responding with a response header. The body of the HTML should include hello YouTube. Be sure to be as precise as possible, because I would like to run on the first go. Browsers are very picky. we're going to go ahead and click this. As soon as we click this, it's going to run locally on the GPU. This isn't out in Chat GPT world. This is local host. So this is my computer is going to solve this problem that I put in here, and we're going to see if it got it right on the first go, because that's our hope, right? Wow, it looks like it's already doing something. I can't tell what processes. Something's using the GPU already. It was working on it. We hadn't even hit send. Now we're going to go ahead and click send. It must already start working on it, because look, it did it again that time. Here the model is thinking. It's using a bunch of the GPU. And essentially it's interpreting what the question that I asked and then building sort of a chain of thought on how to solve that particular problem. And so it's talking about how it can be tricky. It says, wait, actually the user wants a server that follows normal handshakes. Create socket. So now it's coming up with the steps to solve this problem that it's going to have to work on. And so let's go up here. You can see it's using about 126 watts. It's just 100 more than baseline. And here you can see the CPU is using 99%, or I'm sorry, the GPU is using 99% of its total throughput. So it's been doing it for a while here. So you can see it started at like 9:15 and we're already at like 9:16. It's almost been, a couple minutes. Usually it'll tell us here under the thinking once it's done how long it took. But yeah, it's working on the problem. The other thing that I think I could probably show you is the memory. So this is the last hour. So this is probably before we started the AI tests. And you can see how much more memory the computer is using. 19% versus 80% of the total available memory to perform this AI task. It essentially loads the model into the memory. I can see it right in the code right here. So here it wrote the code. I'm going to go ahead and it said thought for a minute. It seemed longer than a minute, but I'll help you create a Python script that meets your requirements. The script will handle everything. So I'm going to hit copy, and then we're going to put this inside of VS Code, newest server.py. And because I've run this test a few times before, and the last time went really good, but unfortunately, that did not work. Okay, so in an effort to just do the right thing with AI, we should read the code first, make sure it's not going to take over the world with this. So you can see right here that this is the main entry point of the Python script, and it is attaching to the socket, it's creating a socket. It's going to bind it to the 7070 port, which means it's listening. Then it sets up a listener. Then within a loop, it's going to accept the connection. And I don't really know what that means. There's a buffer, it looks like. And it looks like it's going to buffer in some data. Once it's done that, it's going to decode it and essentially respond back. And with the response headers and the body, and then send. So we're going to see if it got it on the first go. So essentially do that. We just essentially type Python and then newest Python or newest server.py. You can see here it's running. And so I'm going to move that over to there. And up here, I'm going to open a new tab, and we're just going to type localhost 7070 and see what happens. Uh-oh, I don't think it worked. That's a shame, because last time it worked really good. And when I asked it, bummer. Something didn't work in that one. So let's I'm going to go ahead and control C that. It was trying to answer it. I want to show you the one that I was really impressed by. So I've been asking it the same prompt, and these ones here, the new server one was one of the ones I was the most impressed by, because it actually did a handle request function. It had a main entry point, And then it actually set up threads. So it was actually able to deal with threads. Where this one screwed up, it actually did the content length wrong. It got the content length wrong, so I ended up commenting that out for it. But aside from that, if we run this one, Python and new server, this one here was the other day that I tested. If it immediately says, hello, YouTube. So that one worked pretty good. And then the one I recorded earlier where we lost the camera signal, that's probably this one here. It also worked as well. And we can go ahead and Control C this one. Sometimes this one looks like we used an underscore, newest underscore. Okay, that one's running. I'll refresh the browser and you can see that one worked as well. So it was a little bit different. This one actually parsed out, if I get the right one here, it actually parsed out the protocol in case it was like HTTP 1, 1.1, 2, whatever. And so it was more in compliance with that, and it made it an H1 tag. So AI runs differently every single time, but pretty impressive that my computer can solve this problem that I, as a human being, solved at 13 years old just for funsies. Let me know down in the comments if there's anything else you would like me to test. I mean, it's just normally, it's a Mac that's fast. It has a lot of storage, especially and it's essentially capable of running these AI models. And these will get better. These models aren't really optimized, I don't think, for Mac. Some of these models were built to run on NVIDIA chips, but I think in the future that they'll get more cleanly optimized for the ARM architecture, which is just, it's wild. It's wild how fast this memory is. Subscribe if you haven't already. And I guess let me know in the comments if you have any questions, and don't forget to like all these things, and I'll see you in the next one. Peace.